Welcome and thanks for joining us. My guest today is Chris Rawlings, the group leader for advanced research in cyber systems at Los Alamos National Laboratory. Chris, thank you so much for taking the time.
Yeah, absolutely. Happy to be here.
Absolutely. Chris, we're going to be talking about AI and cybersecurity. AI has probably been the most talked about topic in the tech world this year. It has become this sensation that's been decades in the making. And, it is an exciting time. We're seeing in real time how AI is having an impact across federal agencies on their missions. And it's also just the beginning as they're figuring out their use cases, they're trying to understand how they can use the technology. Also, spending on AI related contracts has massively increased across the federal government. So it's really important to understand the technology is being used in a safe and secure manner. Um, with that, could you give us an overview of how AI is being integrated into cybersecurity efforts at Los Alamos? What are some of the developments that you're seeing in terms of how AI is improving security and, protecting critical systems?
Yeah, absolutely. I like to think of this problem as sort of a natural evolution of some of the work that's been going on, like you said, for decades. Um, AI has its roots going back in fundamental statistics, and it's an interesting time, like you said, because it's sort of a good nexus point where the technology is advanced enough, the compute has advanced enough, and the data required to do the training and to actually make the math work is all converging. And so we've been using sort of traditional statistical methods for a long time to do things like vulnerability detection, malware analysis, malware understanding, insider threat, user behavior analytics, things of those nature. And so we've basically been able to continue that trend and just make those algorithms significantly more complicated and more robust to identifying things. And so we've seen where we are looking at using AI to automate our defenses. So research in how do we automatically defend our networks, your traditional IT networks and OT networks, because at some point we know that the attacks that we have to defend against are going to be automated. They are going to be AI backed, and we have to be ready for that. So we've done a fair amount of work looking at work in that area, and then looking at how we can use AI to accelerate some of the auxiliary work in cybersecurity, because there's the operational side of things, defending the networks day to day against adversaries, but then looking at how do we design new systems that are more robust, that are more reliable, that are very trusted. And so how can we verify that these systems actually do work the way they're supposed to, and augment the scientists and researchers as they do the work in that area.
Yeah, and could you talk about how AI security is different? What types of vulnerabilities AI systems are subject to? And what kinds of vulnerabilities can AI systems create?
So AI is interesting because we have to think of both the traditional like cybersecurity, system security, system engineering problems, and then also the AI problems that come on top of it. And they combine together in a lot of these AI systems. And so we see where traditional cybersecurity problems are sort of manifesting themselves in these AI systems. So things like an AI chatbot being able to have access to a customer database, and it's designed to help people and solve problems. But through like a prompt injection or something else, you're able to get PII of other people, or your someone's latest order, and their address, their name and phone number and stuff like that. And so the one of the sort of specifically hard challenges of the AI problems versus the traditional computer problems is our understanding of them. If you have a firewall, you can go and look and see something is open. It's accessible from the internet. We can go in and we can protect that. We can close that port. If there's something like a code injection vulnerability, we can understand how that works in the code because you can just look at it and see and understand it. For the AI problems, there are so many layers of abstraction, so much math and statistics that we don't really understand quite how they work, let alone how these vulnerabilities are manifesting themselves. And so it takes a lot of work to try and track those issues down. And it could be anything from an AI system doing the wrong thing because it's been tricked to do the wrong thing. It could have learned the wrong thing. You look at all places over the internet, and you'll probably see people making references to 1 + 1 = 3, 2 + 2 = 5. If an AI system has learned that, it has to then be unlearned, and that has challenges in it. You could also run into issues where it reveals the wrong information. So an AI system is trained on petabytes and petabytes and petabytes of data, and you very well may be able to get sensitive information out of that. And how do we protect that? And how do we protect that information and prevent people from accessing it from the AI front?
All the vulnerabilities that you were just talking about, given the ability of the systems to process just huge volumes of data, um, we talk about a lot of the possibilities, and we just touched on, how these systems are uniquely vulnerable. But also, could you talk to the limitations of those systems and what they can do?
Sure, it really depends on the data that they're given, the accesses they're given, and what we as a society, as a company, as an individual, what we sort of enable them or permit them to do. And so, right now, everything in the AI world is based on things that we've already done. It's trying to understand things like sentence structure or trying to understand math that we've done or some computer protocol that we've written. And and in some instances it does a good job of being able to understand that structure. It does a pretty good job with things like the English language. It doesn't do as good of a job with things like computer protocol structures. And even though that's very, very well defined in standards, it doesn't quite understand how the structure of that data works. So while there are lots of places where we see AI being faster than humans or coming up with a more precise answer or a better answer than what we would come up with, it is very much limited on understanding that fundamental data that it trained on, that it learned on. And so one of the things we have to keep in mind too is that it only knows what it knows. It's only learned what it's learned, and it's very easy for it to make judgment errors on why something works the way it's supposed to work. I think of some of the early experiments we were doing with AI red teaming and blue teaming computer networks, and and the way that we were evaluating its success and the way it was working to defend and attack these emulated networks, there were sort of external factors to it. The emulation environment, the hardware it's running on, that caused changes in the system that were reflected in the simulations and the experiments. And the AI system didn't quite understand what was causing those, why it was being caused. It was sort of outside its purview and understanding. And because of that, it did some really weird, outrageous things that doesn't make any sense whatsoever because it didn't have the complete picture. It thought it did, it worked on the data, it knew, and came up with something that is outrageous because it didn't know any better.
Yeah, it's interesting. I was just talking to the Army Chief Information Technology Officer, and we were talking about they just introduced an AI platform, and it's got a lot of great use cases and stuff like that. And we were talking about how people do see when those systems are giving you something really outrageous, like we can identify it, but also at the same time, so we have that human like oversight, um but also I think there is a little bit of that like inclination to like overestimate what those systems can do. We can see it. So how can organizations avoid over trusting those systems, and also how can they mitigate those risks of overlying on those systems?
It very much depends on the mission area, and Los Alamos being one of the three national security labs and one of the three weapons labs, we have some cannot fail missions. And in situations like that, we can't take the risk of an AI system doing something that is wrong, and because we currently can't explain and understand the decisions that AI is making, we can't quite trust them yet. You compare that to some of our more open science work, or an admin or an HR person or a finance person using it to summarize budgets or statements of work, and the risk of those are much lower. And so I think we have to keep the mission use cases in mind. If you talk to some of my AI researchers, they would probably say don't trust them. Go back to the whole trust but verify, or don't trust, and and sort of treat them as if they're hostile, or even if they're, or maybe even just untrusted, and take the answer that they give, but then think about it, and put some humans in the loop rather than on the loop of AI decisions, and try to determine that, does this make sense? Is it the high school physics problem in a 600-mile-an-hour skateboard like that? That just doesn't make sense. And then thinking, how do these systems work? What are some of the vulnerabilities? And so everybody's using AI, trying to accelerate the work they're doing, and whether it be office work, whether it be science, but you have people that aren't used to this field. They're not in it. They're not seeing all the latest greatest papers. They're not doing the research themselves, and so just communicating to them, here are some of the issues, and make sure that they're aware of them. Or the people will see the news headlines, or the headline out of a conference, and they need to remember that the difference between the academic life, the lab benchtop experimentation life, versus real life, when you don't control everything, when things that you don't expect happen, and it may work great in the lab environment in your experiments, but when real life comes at it fails. AI has a tendency to fail in pretty spectacular ways, and people that just don't know that don't know it. And so some of this is educating and people, and just making sure that they are aware of how these things work, and that they do fail. A prime example of this is the self-driving cars that misidentify a stop sign as a 45 mile an hour speed limit sign. we as humans, even if there's a sticker over it or a uh, weather that's happening that's obstructing our vision, we know stop signs are red, they're octagons, and they look very, very different from a speed limit sign. We see a speed limit sign and we may not be able to read exactly what it is, but we know it's not a stop sign, or we know a stop sign's not a speed limit sign. And so there are some of these intuitive things that we as humans have that AI hasn't quite figured out yet. And and I think one of the interesting things with that will be interesting to see how it plays out is looking at how the context of an AI system is taken into account. When we're driving, we are expecting certain things. And we're driving down a highway, we know there's not going to be a stop sign, and we know sort of what all of the road signs look like and sort of what to expect, whereas AI is just processing the data it's receiving and doing what it's going to do. I think as we continue our research and get further down the AI road, we're going to get much better at understanding how an AI, or how certain an AI is of its decision. And so that's one of the big research areas right now that we're working on, is the edges of a decision are easy. I'm 100% certain this is a cat. I'm 100% certain it's not a cat or it's a dog. But what about that middle? And rather than guess and come up with something wrong, saying you don't know is an okay solution. And and if it says I don't know and it's a 50-50 toss up, great. If it's I'm 75% sure, but maybe not absolutely certain, well, that's also useful and good information. And so I think we'll certainly get there, and being able to provide some skepticism to people, a healthy amount of skepticism, and being able to provide some amount of precision or accuracy of these decisions will help people realize it's not perfect, it's not magic, and and people will hopefully trust them with the appropriate level of trust going forward.
Yeah, and could you elaborate on that in terms of what we are talking when it comes to maybe some timelines when we can provide some kind of precision to people?
Yeah, that's a good one. I again, it depends on the area. I think for simple things, we're obviously going to be closer in time than for really complex things. But I think we're still a ways off. I was talking to one of our former lab directors a month or two ago, and he said he took out his old college calculus textbook and fed some of the problems into a system and into an AI system. And he said it got about 80% of them right, which 80% is not bad, but I say it's just college calculus. This isn't anything sort of super new or novel. It's very, very procedural, and we understand that math, but the AI still had problems with it, and some of them were really interesting errors with how it did its math, where he said there would be issues where things would be doubled where they shouldn't have been, or halved where they shouldn't have been. And I'm not sure if this is something in the image recognition process, so it's not understanding the problem properly, or something in its logic. And that's one of the things that we have to be pretty careful of with AI is, are we actually asking the right question? Because AI has a tendency to find intuitive, strange workarounds that may not be exactly what we're asking. And we've run into this when an AI system will sort of run out the timer of an experiment to win, even though it didn't actually do anything. So timelines are hard. It's certainly always going to get better. The worse it'll be from now into the future is what we have now. It's only going to get better. And so, but an actual hard deadline and timeline is hard to say.
Yeah, absolutely. It's all uphill from here. But Chris, you're also in a very unique position of leading advanced research. So could you talk about some of the cybersecurity challenges that you're exploring and anticipating? I mean, we talked about the challenges of AI systems and securing those, but what new potential threats could arise in this like highly automated systems?
Sure. So one of the classic cybersecurity things that we always think about is that the bigger your system, the more complex your system, the more attack surfaces there are, and the harder it is to track down some of those problems and understand why they're happening or think about what may happen in the future. And so we know that our adversaries are going to be doing more and more work in the traditional cyber sense with automating attacks against computer systems, whether that be a automated scan, whether that be automated vulnerability detection, trying to find new 0 days, whether it be self-contained AI system code that's an agent, if you will, that works its way through a network and and learns how we defend, learns how we instrument our systems, and finds creative ways around that. Um, we know that AI is going to be put into systems beyond just cyber. We know that the traditional kinetic offense and defense is probably going to happen at some point. One of my spiels that I always give when I explain AI and how fragile it can be and why we really need to think about this and put the time and effort into it is if a system misidentifies a cat as a dog, dog's a cat, that doesn't really matter. But if we start putting in automated defenses into our military systems and one of our adversaries starts intentionally going at its processing, trying to trick it into doing something, that can have all sorts of unintended consequences. And we have to be exceptionally cognizant and careful of that as we go forward. This ties directly back into the system of AI. How are these systems at a systems engineering level? How are they created? How are they connected? Is it something that with enough poking and prodding, you are able to get it to run code on that system? And it's sort of a modern version of a remote code execution via AI, or persistence via AI, or data exfiltration via AI. And you couple that with some of these really complex military systems or intelligence systems, and it can get scary pretty quick if you jump in and start doing things before you really truly think about all of the threats and all the potential impact. That's what we ran into with the internet. We found this cool new thing and started putting it everywhere. Everybody started using it, started doing all sorts of sensitive work on it, banking, let's say, and the security came afterwards. And we've made that mistake several times now, and so let's not make it again going forward with this new shiny object that everybody's interested in. We
Yeah.
know that the generative media side of things, whether it be videos or text or images, deep fakes, we know those are only going to get better. That's actually where our group got its start in doing the AI assurance work, was probably 6 or 7 years ago in doing deepfake detection before most people sort of even knew what a deepfake was, what AI was. We were working with the Department of Defense and some other government agencies on creating a system to detect these, and it's only getting better. There was a story 6, 7 months ago where a financial analyst was tricked into depositing $25 million, I think it was, into some account because they were on a Zoom call with the CFO, quote unquote, and they thought, oh, my boss is telling me to do something, or the CFO of the company is telling me to do something. So, well, they went ahead and transferred the funds. So how do we trust things? How do we verify identity? I mean, for all I know, this could all be generated by AI. You may not be a real person. It's good enough to do that in today. And then I mentioned earlier, AI is based on what we've already done in the past, and that has some concerns. We know that we can be biased. Are we embedding our existing biases into automated systems and making them automated biases? There was an HR system that was trained on all of the people that had been hired in an organization, and so it reflected what their biases were, whether it be gender, whether it be race, whether it be education, and so we have to be very careful with that.
Given all those challenges, I'm just curious, how do you balance from, your position, how do you balance all those kind of long-term research goals with short-term solutions that are needed, that are just constantly arising?
Yeah, so we're in a pretty good spot. We're rather lucky at Los Alamos because we have multiple cyber groups that are able to focus on sort of different parts of this problem, and different teams that are able to focus on different parts of this problem. And so we certainly have the people that are doing the day-to-day firefighting, that are defending the networks currently, that are looking at things that are currently operationalized and being used by the military, by the government, by Los Alamos ourselves, and trying to understand those and protect those. We've got people that are able to look at the medium range terms, so things that are coming down the pipe fairly soon, that there aren't sort of big research problems around, and we're able to help address those and think about those sooner rather than later. And then the teams that are able to focus on the longer term things. And, so I mentioned that our AI assurance team has been working on doing work in the AI space for 6 or 7 years now, which is significantly longer than sort of most people have cared about AI. And it very quickly went from an academic research into reality, and so we you definitely do have to keep those things in balance. And so we never want to sort of forego the future in exchange for the present, for tomorrow, but we have to be cognizant of what we have to do now in order to work in the future, and in order to stay competitive and stay on top of things. And some of these big problems, like trust and understandability, reliability, are big problems. And if we aren't putting in the time and effort now, we're just going to get further and further behind. This technology, and all technology for that matter, it doesn't grow linearly. We think back to Moore's law, with the number of transistors on a chip doubles every 18 months. That's an exponential growth. And if we don't put in the time and effort now for the fundamental work, we're going to be forever playing catch up. And especially when we look at what our adversaries are doing it in this arena. We can't wait, but we can't not think about the immediate concerns of today either. So it is a challenging balance, and I think that that walking that line is challenging, and there's not really a single right wrong answer for how to do this, and it's really just a matter of trying to make sure that you don't get too behind in any single one area, and keep making progress, and being able to move and sort of flex and bend to the different areas and different emphases as needed based on what's happening. If there's some big new vulnerability or issue that happens, that obviously gets priority. But once that's been resolved and things are sort of back to normal, being able to switch and be more forward looking, proactive versus reactive.
Sounds like a lot of teams are working together at Los Alamos, but also could you talk to maybe your collaboration with other labs and federal agencies? What are some of those shared efforts that contribute to advancing AI and cybersecurity? Could you give some of the most recent examples of those successful partnerships?
So this is AI is such a big problem. There's a fundamental recognition that we can't do it alone. We have to work together. We have to work together as a department, as a whole federal government, and even bringing in non-government partners like academia and private industry, and and so there's a bunch of work happening that is very NNSA or Department of Energy focused, and then a fair amount that is external. So there are a number of projects that are happening in the non-proliferation space that we are partnering with Oak Ridge National Lab, Lawrence Livermore, Sandia National Labs, Idaho, Argonne National Labs. Uh, there are instances of working with the Department of Homeland Security, with working with our intelligence community partners, working with various organizations within Department of Defense, and that's both in applicable work that is sort of more near term, but then also more long term research, because they recognize that we need to be flexible and we need to be forward looking. And so that's everything from looking at like communication systems and ensuring their robustness, their reliability. That's looking at formally verifying systems. So that's a fair amount of work with the Department of Defense. How do we know that these systems are going to be reliable should they ever be needed in a wartime situation? Uh, a fair amount of work with academia in terms of fundamental research, and trying to sort of transition and inform them of the work that we need to do from our national security perspective and from our science perspective, and how can we build that collaboration with universities, because they are absolutely phenomenal at doing a lot of very high risk, low TRL research that may have single digit percent chances of success. But that's what universities are for. They're for pushing the absolute cutting edge of research, and and so being able to help fund that and being tied into that and guide that is key for helping us continue to push in the science world, and ensure we don't stay behind, or that we don't get behind, because if we sort of stop pushing the state of the art and pushing things forward, we're just going to start lagging further and further behind.
And could you talk to, you mentioned that, you mentioned pushing for cutting edge research. Could you talk to your ability to scale solutions? What are some of the challenges there?
Yeah, so it really depends on what it is you're trying to do.
Mhm.
In some instances, you very well may be limited by your compute resources, and in other instances, you may be limited by the data. You very much run into problems where it's the combination of those two things, where you have the compute but not the data, or you have the data but not the compute, or the data is geographically different and separated from where your compute is. And so we think about things like it'd be great if we could look at our satellite constellations and how are those covering the Earth, and what are the things that we want to focus on and prioritize. But if we can't get the data to make those decisions of things like orbit paths or time over a particular target of interest, then it's kind of useless. Or satellites don't necessarily have the most computing power, so it may have all the data in the world, but it isn't able to make use of it. And so those are two big problems with sort of scaling problems or scaling solutions. Also, we run into the issue of things like power constraints. AI can take an absolute ton of power, and it may not be possible to get to have that amount of power needed wherever it is you're operating out of, whether it be something on orbit or a contained instrument or piece of equipment, and you may be constrained in that regard. So so there's a fair amount of technical challenges depending on what it is you're trying to solve, and and some of them have more elegant solutions than others. Some of them require a bit more creativity in trying to make them operational. You also outside of the technical world, you run into things like policies and procedures that cause challenges. There are lots of projects and programs and agencies that really truly want to use the latest greatest technologies, but the way that something like a system accreditation works, or how do you protect data, or just the time required to operate a system for federal data, and that in of itself can be a challenge to overcome. So you have this great idea, you've shown it works in a proof of concept, but now you want to scale it out and do a lot of computation, machine learning, AI work, whatever it is that you're wanting to do. And in order to do that, you need to use things like a cloud platform, or you need to use a commercial AI solution, or whatever it is. And and it just takes time. And so ironically enough, that's one of the things that we're looking at accelerating using AI, is how can we get AI systems and sort of cloud systems and new compute systems approved for use faster. And and it's sort of the what I think of as the next evolution of a federal system accreditation. It's not the most exciting topic in the world, but for the longest of times, the computer networks, federal systems were pretty plain Jane and boring. You had a bunch of desktop computers, you had a bunch of laptops, you had a data center somewhere on site, and everything was nice and contained and behind your firewall and all your protections. But with cloud services, whether it be a infrastructure as a service, so building a network in the cloud, whether it be a service as a service, we think about things like zero trust. We think about things like people working remotely how can we enable that, and how can we enable that for the variety of missions in science that happen.
Yeah, absolutely, Chris. And before we wrap up, what are some of your priorities for the remainder of the year and also for 2025?
Yeah, so we've got a whole slew of things we're looking to start working on or continue working on. One of the ones I sort of alluded to this a little bit earlier.
Hmm.
Um, Everybody is enthralled with AI and is looking forward to it and wanting to use it, but there's a fair amount of education and learning that has to happen with people who aren't in the AI domain, whether that be chemists or physicists or biologists, or whether it be a senior leader who you know, they hear about this, they see the headlines, but they don't really understand it quite yet. So how do we increase that awareness and understanding of systems so that we make the right decision sooner rather than later, and don't have to double back on ourselves and sort of fix problems that we unintentionally created for ourselves. Outside of the sort of the AI world, we've got a number of things going on that's pretty exciting. So one is the CyberFire training program that we run for the Department of Energy. We are hoping to make 2025 the first international event, so we are very much looking forward to that. In sort of the microgrid distributed energy resources field, we are looking at doing some equipment upgrade here on site to upgrade our microgrid, adding in things like solar, batteries, other renewable energy resources, and trying to look at how do we communicate, or how do we secure those communications. You know, as the grid moves to more renewables, that communication component becomes increasingly important, because you don't have big spinning turbines in natural gas or coal, and so how do we ensure grid stability? You know, that's a big problem that we have to think about. Doing a fair amount of work in the quantum world, whether it be quantum key distribution, whether it be quantum computing, or how do we make that transition from sort of the classical era to the post quantum era. You know, NIST relatively recently came out with their post quantum algorithms, and so that's a pretty dramatic change for the government, for society as a whole, and how do we make that transition gracefully. And sort of lastly, one of the really exciting things we're working on is some of the anti-ransomware work. You know, that's a huge problem still. It's been around for years and years, and we're hopefully going to make a bit of an impact in that, in the government and critical infrastructure space going forward.
Okay, that's a lot of exciting developments. Chris, thank you so much for joining me today. We're unfortunately out of time, but what a great conversation.
Yeah, absolutely. Thanks for having me.
Of course. Again, I'd like to thank today's guest, Chris Rawlings, the group leader for advanced research in cyber systems at Los Alamos National Laboratory. I'm reporter Anastasia Obis, and you're watching Federal News Network. Now let me send you back to the studio for more on the Cyber Leaders Exchange.